May-June 2023, paper 4 and 4.1 is the variant. First question of this paper is from momentum. We will use here the law of conservation of momentum. This question number 1 is from momentum. Two particles P and Q of masses mkg and 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected at a speed of 5 meters per second directly towards Q. This is the speed of particle P towards Q. After P and Q collide, P moves with speed of 2 meters per second in the same direction as it was originally moving. Part A of this question is find in terms of m the speed of q after the collision. Now this is particle p and this is particle q. P is projected directly towards q. Now the mass of particle P is given, that is mkg, and initial speed of P that is given 5 meters per second. This is given. P is projected at speed 5 meters per second directly towards Q. This is the speed of P. We will consider it as the initial speed of particle P, and after P and Q collide, P moves with the speed of 2 meter in the same direction as it was originally moving. So we are after collision we will represent the speed of P as with Vp. Vp means speed of particle P after the collision that is given in the same direction as originally moving. This is 2 meters per second. In the same way, the mass of particle q is represented by mq, that is given 0.3 kg. A particle q is at rest, so initial speed u q is 0. And now we are using here law of conservation of momentum. Momentum before collision mp up plus mq uq is equal to, this is momentum before collision. Momentum will be equal to mass into speed, mass into velocity, that is the momentum of particle p before collision, momentum of particle q before collision, and moment is equal to momentum after the collision, that is m p v p plus mq vq. Now putting the values, mass of p is m, initial speed is 5. So we write here m into 5. Speed of initial speed of q is 0. So we will write here 0. On the right side, mass of particle q is uh, on the right side, MP and VP. MP is M and VP is 2. So we write here 2M plus MQ MQ is 0.3 and VQ we have to find. We have to find speed of Q after the plane, that is VQ we have to find. VQ we have to find. So 2m plus 0.3 into VQ. From here we can find the speed of Q after the collision. 5m is equal to 2m plus 0.3 VQ. 3m is equal to 5m minus 2m, that is 3m. So it becomes 3m is equal to 0.3 VQ. From here, VQ will be speed of Q after the collision will be, after calculation we get 10 meter per second. Now part B of this question is after this collision, Q moves directly towards a third particle R. After the collision of P and Q, Q moves directly towards a third particle R. The mass of R is 0.6 kg, which is at rest on the plane. Q is brought to rest in the collision with R. Q is brought to rest in the collision with R, and R begins to move with the speed of 1.5 meter per second. Find the value of m. Now again, we will consider in this case, in this part, the collision of particle q and r. So let this is particle q, and this is r, particle r. Mass of q is already given, that is mq is 0.3 kg, and initial speed of q, just we have found this. For this case we are taking this 10 meter per second is the speed, initial speed. We will take it as initial speed of particle q, that is 10 meter per second. vq, particle q is brought to rest in the collision with r. So after the collision, the speed of q is 0. Speed of q is 0. Now in the same way, mass of particle r is, that it is represented by mr, is equal to, that is given 0.6 kg, and it is initially, it is at rest. So initial speed of r is 0, and after the collision with uh, uh, after the collision of q and r, speed of R is given, that is 1.5 meter per second. So VR is equal to 1.5 meter per second. Now again we are using here last conservation of momentum. MQ, momentum before collision, is equal to momentum after the collision. MQ UQ plus MRUR is equal to MQ VQ plus MRVR. Putting these values here, MQ is 0.3, UQ is 10 meter per second, 10, sorry, this is 10 m, because the speed is, we have found the speed of uh, uh, the speed in the above part. VQ VQ is 10 m. VQ is 10 m because it is in terms of m, 10 m meter per second. Okay, so the speed of Q is 10 m. Putting here the values, UQ is 10 m. Initial speed of R is 0, so this factor, this term is 0. On the right side, MQ is 0.3, VQ is 0 because after the collision speed of Q is 0, plus MR is given, that is 0.6 kg, and VR that is 1.5. It is given speed of R after the collision, that is 1.5 meter per second. From this equation we can calculate the value of M. Simplifying, we get uh, 3m, left side is 3m, on the right side 0. This is 0, first term is 0, the second term is 0.90. So from here m is equal to 0.90 over 3, we get the value of mass is equal to 0.3 kg. This is the answer.